Welcome back guys. Now in this video let's discuss about the touch receptors. See, in our skin there are receptors as well as the vibratory sensation also. So these receptors are also called as the tactile receptors. Touch receptors or tactile receptors, both are same things. Now you can see here in our skin there is epidermis, dermis, these layers are there. Now in the skin you can see there are different types of receptors. All these are different types of receptors. Okay. So why do we have different types of receptors? Different types of receptors will detect different forms of touch, different forms of vibration. For example, like fine touch, okay, crude touch, high frequency vibrations, low frequency vibrations, like pressure. Okay. So to detect different forms of touch, we have different types of touch receptors. Now first let's see what are the names of those touch receptors or tactile receptors. See, there are Merkel cells, Meissner's corpuscles, Pacinian corpuscles and Ruffini's corpuscle. All these are different types of touch receptors. Okay. So let me give you a mnemonic like MRP. Okay, MRP or MMRP, like maximum retail price, something like that. Okay. So what does this MRP stands for or MMRP stands for? Meissner's corpuscle, Merkel cells, Ruffini's and Pacinian. So these are the 4 different types of touch receptors. Others are also there, but these are the 4 important things which you need to know for your exam. Now how the questions are going to come up in your exam? How can you expect the MCQs? See, they will ask you different types of, okay, see, these are the different types of touch receptors. They will detect different forms of touch. So these different types of touch receptors are going to detect different forms of touch. For example, Meissner's, they will ask Meissner's, what it's going to detect. See, these Meissner's corpuscles, first of all, they are present in non-hairy skin regions, non-hairy skin. Okay, non-hairy skin regions, also called as a glabrous skin. Okay, glabrous skin. Like where do we have such non-hairy skin? Like palms, soles, okay, lips, in these areas. Okay, the Meissner's are only present in these areas, like glabrous skin areas. And what do they detect? See, these Meissner's corpuscles, whatever were there in my skin, what are they detecting? They are detecting fine touch. Okay, they are going to detect the fine touch and low frequency vibrations. Okay, fine touch and low frequency vibrations are detected by the Meissner's corpuscles. And there are also good receptors for detecting the 2-point discrimination, 2-point discriminatory sense. Okay, but the best receptor for detecting the 2-point discrimination is Merkel's, but Meissner's can also help in the 2-point discrimination. Next, let's discuss about the Merkel cells. What these Merkel cells are going to detect? Important point. Merkel cells are the only touch receptors which are present in the epidermis. All others present in the dermis, but the only receptor which is present in the epidermis is Merkel cells. Present in location epidermis. Okay, they are located in the epidermis. Next, the only uncapsulated receptor. This is the only uncapsulated receptors. All others are having a capsule around them. All receptors are capsulated, but this is the only uncapsulated receptor. Okay. Next, Merkel's, they are going to detect the sharp edges and corners. Sharp edges and corners. Okay. Wherever there is a sharp edge or a corner of a table, that sharp things will be detected by these Merkel cells. Okay. And these are the best receptor for, these are also going to help in the 2-point discrimination. They are also going to help in 2-point discriminatory sense. Okay, these are the best receptors. Merkel cells are the best receptor for 2-point discrimination. So ability to discriminate between the 2 different points. Okay, 2 different points. So our sensations are like our skin is so sensitive that we can discriminate between the point number 1 and point number 2 which is present on the table. Imagine there is a table. On this table, there are 2 points present. Let's say within a very small distance, here is a point number 1 and here is a point number 2. 2 points are there, 2 elevations, 2 little elevations are there. Okay, the distance between these 2 points is very, very less. Our sensations are so sensitive that I can discriminate the point number 1 from point number 2, from point number 3, from point number 4, from point number 5. It means I can read those points. So this will help in reading Braille script. Okay, so Merkel cells helps in, these are the best receptors for reading Braille script. Helps in reading Braille script. Okay, so these are the important points about the Merkel's. Merkel's location epidermis is the only receptor present in the epidermis and it's the only uncapsulated receptors. All others are capsulated. They are going to take the sharp edges and corners, and these are the best receptors for reading the 2-point discrimination and helps in reading Braille script. Next, what about the Pacinian corpuscles? See, these Pacinian corpuscles, first of all, I want you to know this is an image based question. Okay, you can expect an image based question from this because receptor, okay, is going to look something special. Guys, look at here, Pacinian corpuscle in the brackets. Okay, I have given Pacinian corpuscle. See, it's a lamellated corpuscle. Lamellations means what? Layers or whorls. So, look at this receptor and tell me how it is looking like. At your first look, you can very clearly say it's looking like an onion. There is a ring kind of appearance is there. So, yes, Pacinian corpuscle is like an onion ring. Okay, it's like in the shape of the onion rings. Lamellations are there. It's capsulated. Okay, and first of all, tell me, where are they present? Are they present superficially? No, they are not present superficially. They are present deep. So, they are going to detect deep touch, deep pressure, high frequency vibrations. Okay, so right, Pacinian corpuscles, they are going to detect deep pressure. Okay, deep pressure. They are going to detect crude touch. Okay, high frequency vibrations. High frequency vibrations. In fact, these are the best receptors for vibratory sense. The best receptor for the vibratory sense, if they ask you, it doesn't matter low frequency vibrations or high frequency vibrations, the best receptor for the vibratory sense is always Pacinian corpuscles. Okay. Next, apart from that, I have told you these Pacinian corpuscles, they are in the form of whorls, lamellated. Okay. Again, I am writing here, important, lamellated. These are lamellated corpuscles. Okay, done. Next, what about the Ruffini endings? See, these Ruffini endings, they are going to detect skin stretch. Okay, skin stretch. Whenever there is a skin stretch, okay, on your body, whenever the skin is getting stretched, you can feel it. Okay, so that skin stretching is detected by the Ruffini ending. Okay, fine. Next, so these are the important receptors and the important MCQs. Now, what else they will ask you is, see, every receptor, I have told you, every receptor is attached with a first order neuron. Okay, that's our basics. Every receptor has to attach with the first order neuron, and the first order neuron has to take the information to the dorsal horn of the spinal cord. Now, even these receptors, look, these receptors, every receptor in your body, it is attached with a first order neuron. You can appreciate here. Every receptor is attached with a first order neuron. And where these first order neurons are taking the information, they are taking the information to the spinal cord, dorsal horn of the spinal cord. So, what is the name of this first order neurons? This is what they will ask you. Okay, what is the name of this first order neurons? The name of these first order neurons are called as the A beta neurons or A beta fibers. Okay, so the A beta neurons, and the A beta fibers are the first order neurons from these receptors. Which receptors? Touch receptors. So, how the question you can expect in your exam is A beta fibers carries which sensations? A beta fiber carry which sensations? A beta fibers are going to carry the touch sensations. Okay, they are not carrying the they are not carrying about the pain, they are not carrying the information about the temperature, they are carrying the information about the touch and vibrations, okay, and also pressure. Now, after this, what else you should know regarding these receptors is the concept of receptor adaptation. What is receptor adaptation? See, now when something is coming into contact with your body, will we feel it or not? You tell me. See, when something is coming into contact with our body, yes, we will feel it. But I am asking you, from the morning you are wearing rings, okay, you are wearing rings, you are wearing spectacles, you are wearing shirt. See, they are continuously into our contact with our body, right? There is a continuous contact, there is a continuous stimulation. But are you feeling it? No, we are not feeling it. Consciously, we are not feeling it because continuous stimulation, continuous, same intensity, non-harmful stimulation is going to make the receptors adapted. the receptors will think, why to give this information unnecessarily to the brain, why to give us signals to the brain, why to give the sensory overload to the brain. Okay, not unnecessary, right? This is a non-harmful, to same intensity stimulus. So if you are giving us continuous non-harmful same intensity stimulus for certain time in an area continuously, the receptors, the touch receptors in that area will undergo adaptation. They do not produce action potentials, they do not produce electricity. Okay, they won't undergo depolarization. Okay, you can say something like that. Okay, so this is called as a receptor adaptation. Some touch receptors are fast adapted and some are slow adapted. Okay, so let's see what are the examples of fast adapting receptors. Fast adapting receptors, fast adapting touch receptors includes MP. Okay, you can remember like MP, Meissner and Pacinian are examples of the fast adapting receptors. And what are the examples of slow adapting receptors? Slow adapting receptors includes Merkel's, Ruffini's and free nerve endings. But for now, just remember MR, Mr. MP. So Meissner's and Pacinian are examples of fast adapting, and Merkel's and Ruffini's are examples of the slow adapting. Fast adapting are also called as a phasic receptors. Slow adapting also called as a tonic receptors. Okay. So with this, what we have completed, we have successfully completed the topic of touch receptors. Again, what are the important MCQs? What are the, tell me 4 examples of the touch receptors? Meissner's, Merkel, Pacinian, Ruffini's. Who is going to take the Bailey's reading? 2 point discrimination, best for the 2 point discrimination, Merkel's. Encapsulated one, Merkel's. Epidermis, Merkel's. Fine touch, Meissner's. Low frequency vibrations, Meissner's. Meissner's can also help in detection of the 2 point discrimination. Next, who is going to take the deep touch? Pacinian. Deep pressure, Pacinian. High frequency vibrations, Pacinian. Best receptor for vibratory sense, Pacinian. Skin stretch, Ruffini's. What are the first order neurons called as A beta fibers? These touch receptors can undergo fast adaptation as well as slow adaptation. Fast adapting are also called as phasic and slow adapting are also called as tonic. Examples MR and MP. Okay, so that's it. So with this we have completed the topic of touch receptors. Hope the video is helpful. Thank you.